we'll just go in order. So we are not solving systems, if only that was what we were doing, then we can be happy. No, we are going to be dealing with radicals. Specifically simplifying them. But in order to do this, we need to lay down some context. And that's going to be a rehash of our rules of exponents. And your book really does a lot of assuming here that you know these rules. So we're going to go over them just to make sure. So our first rule of exponents is going to be the product rule. Now, unfortunately, this is not what your section's on, but it's what you need to know in order to be successful at this section. So our product rule is, if I have, say, x to the a times x to the b, then I add my exponents. And as an example of that, I don't want to do too many examples of this because I don't want to take up all the class like doing this. But I add my exponents there, and I get x to the 6th. And our temptation here is to multiply those because we're multiplying, but that's not what we do. And the reason we don't do that is because if I look at what an exponent means, that means x to the 4th means x times itself 4 times, and then x squared 2 times, and then how many of these do I have? Well, I have 6 of them. So that yields my x to the 6th. So it's faster to add them. Do you see what I'm saying there? I know I went through that fast, but the rules of exponents, if we're multiplying, what do we do with our exponents? We add them. Now notice, the base is the same, right? Okay, that's important. I couldn't do that. If I had x to the 5th times y squared, I couldn't actually do anything here. Quotient rule, if I'm dividing, now that could be like with a division symbol or as the result of a fraction. So I could also have this, x to the a over b, x to the b, like that. But in the end, opposite of multiplication, I'm going to subtract my exponents, right? So for example, if I had x squared divided by x to the 6th, what do I do with my exponents?
You subtract them.
I subtract them. What do I get? What's 2 minus 6? Negative 4. And now that brings us to a related problem. What are we going to do with that? So I did run out of room right here, so I'll just like over here. If I write this as a fraction, okay, I can see what's going on better. X times x, right? And then I have 6 x's on the bottom. And then I can cancel. So what's left in the numerator? A what? Oh no, wait a minute.
You got 4.
I got a 1. Because they canceled, right? It doesn't cancel to a 0, it cancels to a 1. So how many x's do I have in my denominator? 4. So that brings me to I move that down, okay, if I have a negative. Now I don't always get a negative, but sometimes that happens. Okay? Let's get our third rule, the power rule. This would be like x to the a, then to the b. And this is when I'm multiplying, then I get ab. So if I had, for example, x squared to the 3rd, I am going to get x to the 6th this time, not x to the 5th. I don't add those. And the reason why is because this means x squared times x squared times x squared. Well, then using the product rule, I would add all those and get x to the 6th. And just to do another example of that, if I had, this is where we get tripped up, if I have 5x cubed squared, that's going to mean 5 squared x to the 6th, which is 25x to the 6th. So we usually forget this number right here. That's part of it. So why does it come out that way? Well, this means 5x cubed times 5x cubed. And I get that. Okay? One more rule, and then we can actually start what we're supposed to be doing today. Fourth rule, 0 power. And pretty simply, anything to the 0 equals 1. Okay? Doesn't matter what it is. So if I had x to the 0, that's 1. 100 to the 0, that's 1. Big, nasty, ugly. Put it to the 0, equals 1. Okay? Does not matter. Anything to the 0 power is 1. And that's going to be very useful when you're simplifying. If you see that, change it to a 1 right away. So you don't have anything too horrible. I lied. There isn't another rule, but I want us to do some really ugly ones so that you see how you simplify these. And then we can do what we're actually supposed to do. Alright, so let's say I have this. So that doesn't look too bad, but all these negatives, like what's even going on? So I have a power to a power, right? So what do? Multiply. So I'm going to get 1, because that's going to be to the negative 1, so that doesn't matter. And then what's negative 2 times negative 1? 2. Alright, now I'm multiplying, but what's the denominator on this second thing? 1. So I get x cubed over x squared. Subtract my exponents and I get just x. Okay? So what did I use here? Rules of fractions to go ahead and multiply. Quotient rule. And up here I used power rule, right? And right here I just multiply. Top times top, right? Bottom times bottom. That's how I worked through that. In general, I'm going to do power rule first. Why? Exponents first. But they're all exponents. Well, exponent of an exponent. So power rule first. Then I like to do the product rule. And then I do the quotient rule. I typically do quotient rule last. But you don't have to. You could do quotient rule first if you wanted to. Alright, bam. Let's do an even uglier one. Now, we could do A's and B's. It doesn't matter what the letters are. That's going to be -3. There's a smudge on the board that's making that weird. What do you think you should do first?
Powers.
Yeah. So I have this first thing, and I'm just going to leave it alone. Now I could move that y cubed up, that negative cubed up. I could do that. I'm not going to bother. Because this next thing is going to get nasty. So I get x to the what?
-2.
Y to the
3.
Okay. Now what's the denominator on this? 1. Alright, now I'm just going to do top times top, bottom times bottom. Now what am I going to do? So this was power rule. We power ruled this. Then we multiplied. And then right here, what are we going to do? We're going to do quotient rule. So what do I do with my exponents?
You switching.
I subtract them. I don't switch them. I subtract them. So negative 2 minus how much?
2.
Y to the third minus what? Negative 3. That's a negative 3. We need to watch our signs. So that gives me negative 4. And this gives me y to the what? 6. And I'll just move over here. That leaves one step. Whenever I end up with a negative exponent, I'm going to either move that up or down. So if I move that down, it switches to a positive exponent.
So that's the y to the third. Down there a little bit. Down again. Down. What is that? Extra one. Up again.
3 minus negative 3. Because this was a negative 3. So 3 minus negative 3. We could have just written that as a plus, but I wanted to make sure that you saw where it came from. And our last step, when we had this x to the negative 4, we moved it on down. Some students like to move all their exponents, negative exponents up, like some students would move this y up and this x down and then multiply, and that's certainly fine. You can do that. I don't like doing that because it's a lot of extra stuff, probably will make an error. Of course, there is the other thing, where we would have a negative here. And if you don't treat that right, you'll have a problem. Should we do one more of these? Yeah, let's do one more and then we'll just call it, because we haven't even touched on what we're supposed to actually be doing today. Okay. What should we do? Power rule first. Always power rule first. So we have r squared, x to the 4th, y to the 6th. In the denominator, what will I have?
R to the 6, x to the 4, y to the negative.
Okay, so we did power rule. Now we're going to do quotient rule. Do you see why? So what do I do with my exponents? Quotient rule. So I have 2 minus 6, 4 minus 4, and 6 minus negative 4. Do you see where I got that? So I get r to the negative 4, x to the 0, y to the 10. So x to the 0 is what? 1. What am I going to do with that r to the negative 4? Move it down. Okay? When I do this division, actually everything ends up in my numerator. So then I need to move it down. So we need to remember x to the negative a equals 1 over x to the a, which I guess should have been our 5th rule. Okay, we are going to say that's good. Whether it is or not, I don't know. But we will say it is. So now we're going to do roots, which is what we're actually supposed to do. Roots. So, what's the square root of 100? What's the square root of 100?
45. Wait.
10 or negative 10. And let's think about why. Here's what we're asking. We are asking, and what's our, this is a 2 here because we're doing a square root. We are asking,
Back to the last slide real quick.
I will in a moment. We are asking what number times itself twice gives 100. That's what we're asking when we do a square root. So we say, well, 10 times 10 is 100, or negative 10 times negative 10 is 100. Now, for this chapter, we're going to want the principal root. And the principal root is the positive one. So we'll take this one. Okay? All right, let's do this one. Cube root of 27. Now, I'll tell you, I'll show you why this is the answer, but the answer is 3. Okay? For now, just take it on faith that that is the correct answer. Now, there is no or negative 3 because of what we're asking. Here's what we're asking. We are asking what number times itself, how many times? 3 times gives 27. And we see, like up here, 10 times 10 is 100. Okay, I multiplied 10 times itself twice. 3 times 3 times 3 is 27. 9 times 3, 27. Okay, so what's my answer? The 3 is the answer, because 3 times itself 3 times is 27. So here's our thing, and then I'll go back to the previous slide. This number right here, above the little hump, that's our index. That tells me which root I'm taking. And this is a radical symbol. And right here is the radicand. Okay, that's the number we're taking the root of. And we can take any root that we want. So that's what we want, a general, like, how do we take a root? Now, you might be wondering, well, why didn't I have a negative 3 over here? Why didn't I have, like I had with a negative 10? Well, negative 3 times negative 3 times negative 3 is not 27. I'd get a 9 times negative 3, which gives me negative 27, but that's not what I started with. Okay, so that's why I didn't have negatives. That doesn't work out. All right, so real quick, back to the previous slide. That's what we had. So you can finish that. And then we are going to go on. So what we want to do is simplify these radical expressions exactly. Well, how do we do that? Oops, and ignore this parallel, that was the algebra class. They get to draw lines now. If only we could do that, right? So what if I have the square root of 48? Now, I think your calculators will do this exact, in which case you can check your work, okay, and see that you're doing it right. But if you don't have one, in either case you have to do what I'm about to do. We need to prime factorize that. This is one method to do it. There are other methods to do it. We'll just decide that this is the way we're going to. So we're going to take this 48, and like back in 5th grade you learned to do this, right? We asked, well, I can divide that by 4. I just keep on dividing this, right, until I get primes. Now, if I'm assuming too much here that you know what I'm actually doing, please speak up. And I got all primes here. And we need to understand what a prime is. A prime is a number divisible only by itself and 1. Now, we don't count 1 as prime because that's cheating. So the first prime number is a 2. So we just keep on dividing each of those numbers till we can, until we branch out. And then this row, if I take all that row, now how many 2's do I have? 4. So I'm going to write 2 to the 4th power times, how many 3's do I have? 3 to the 1st power. Now, what's my index here on this if it's not written? A 2. right? So I want all of these exponents, I want them divisible by 2. Is 4 divisible by 2?
Yes.
Yes. Okay? And the 1 is not divisible by 2, but I can't do anything about that. So, the square root of 2 to the 4th is 2 squared. So I actually could do that one, but this 3 I can't do. So I'm left with that. Now I simplify. 2 squared is 4, so I have 4 root 3 is the exact answer. Now, as weird as it may sound, I actually think it's easier to see what's happening if I use variables. So let me try it with a variable. Let's say I'm doing the square root of x to the 9th times y to the 6th. Now I'm doing a square root, which means I need my index. My index is 2. I'm doing a square root. I need these to be divisible by 2. Okay? 9 is not. Now this time I can do something about that. I can split that up using my rules of exponents, which is why we did the rules of exponents to begin with. Instead of multiplying and getting the 9, I'm going to go backwards and ask, well, what could I multiply to get the 9? Now I want to work from 9 backwards, and I get 8. And the 6 is already divisible by 2. Now why do I want it divisible by 2? Because my index is a 2. Okay? And we'll actually see later in the chapter why it's working out that way, but for now we'll just use it. So now I'm going to take that and, well, what's 8 divided by 2? So I have x to the 4th. So I could do that one. Can I divide the 1 by 2? No. And what about this y to the 6th?
Y to the 7th.
Okay, and I have square root of x is left. Now I don't need to write that 2, but if it were any other index, then I would. So that's my answer. Now, we could deal with absolute values, as in emphasizing the fact that I don't have negatives out here. But for now, let's not worry about it. Let's just get this. So if you're checking your answers in the back of your book and you see weird like absolute value symbols around things, don't worry about that for now. Okay? We'll get to that later. Any questions on how I got that? Let's try one with an index that's different. Let's try a third. So we're going to do a cube root. Now I need these to be divisible by what? 3. Okay? In this case, the 12 is fine. So I'll just leave the x to the 12 alone. But what about this 20? It's not good. So I need to split it up so it's divisible by 3. So I'm going to write, now I'm going to count back from 20. How about 19? Is that good? No. How about 18?
Yeah.
Yes. So I have 18. So this one, in this one, I can do the y squared. I can't do. What's the cube root of 12, x to the 12? And the cube root of 18? Cube root of y squared is left. So that's my answer for that one. Sometimes you have the letters mixed with the numbers, so we'll do one of that. Then actually we have done what we need to do today. Let's do a 4th root. Why not? 4th root. I can't forget this number. Okay? Our tendency is to want to ignore it. We cannot do that. I take my 32, and I'm going to prime factorize it. Now, rather than copy down numbers like I did the first time, what I do is I like to just circle them once I get a prime. So these are all my primes. That way I see them. So those are all my primes. So I'm going to rewrite that 32 as what? 2 to the 5th. And you're right, I am going to split it up soon. I need to split it up so it's divisible by what number?
2 or 4.
4. So I am going to have 2 to the 4th times what? 2. X to the 4th times x. What about that y? Y to the
16.
times. Now, I do want to make a note of this. Could I have written that 18, when I split up that 18 as, say, y to the 10 times y to the 8? Could I have done that? Yes, but it's going to lead me down the wrong path. Because, could I split up that 10 more? Yes, I can, right? So, I always want to start with the biggest number. So I'm going to start at the 18 and work backwards until I get to the divisible. So what's the 4th root of 2 to the 4th? 2. What's the 4th root of x to the 4th? And I can't do the 2 or the x. How about the 4th root of y to the 16? And then everything else is left in here. So I have a 2, an x, and a y squared. And that'll be our answer. Again, not accounting for any negatives. I want to make this note, and just so you know, there are negative answers to odd roots of negative numbers. So, if I did the cube root of negative 27, the answer is negative 3. Okay, I just do it like I normally would with positives, but it's negative in the end. Okay? But, that should have been there are. There aren't negative answers to even roots of negative numbers. Okay? That would be imaginary, right? Now, if you want to switch to imaginaries and do it, that's certainly fine. You can do that. But, yeah. Alright, I want you to do a couple in your notes on your own, and just to check to see if you are getting it, and then we'll go to the whiteboards. Simplify these exactly, and as far as possible. Okay, I'll go back in a moment. Just get these down. Throw in a few trick questions. Okay, so get those down. I'll go back quickly to the slide then that you're missing something on. Okay, you needed the previous slide? I take it you need the bottom, so I'll read it to you. There are negative answers. There are negative answers to the odd roots of negative numbers. There aren't negative answers to even roots of negative numbers. So if I have an even index, and I'm taking the root of a negative number, I'm not going to get a real answer. Would be on the imaginaries. So we aren't going to, for this chapter, we're not going to worry about imaginaries. Okay, so go ahead and give these each a try. What do we get for the first one?
6x squared. No, 9x squared.
9x squared. Yes. So when we prime factorize that 81, we would get 3 to the 4th. Which gives us 3 squared x squared. Which gives us that. I'm not always going to show the prime factorization because that is time consuming. So I'll only show it if there really is a big question on where I get that. But ultimately, for all the numbers, we get the exponents and the bases by prime factorization. The next one, what do we get?
A to the 4th.
Okay. And the next one.
X to the squared, y to the 4th.
Yep. How about the next one?
4x to the 4th.
How about this one?
Would you have to do something about that x squared?
Okay, so this is where, and that's why I put this up here. I'm going to do it wrong on purpose, and and anyone can fall for this. This is how I did it in school, in high school, and got them all wrong. Okay, very bad assignment for me. Here's the wrong way. -7 times -7 is 49, and the square root of 49 is 7. Wrong. It makes sense though, right? Boy, did I get suckered in. Got them all wrong. Okay. This is a square root, right? A square root is going to undo the square if the answer is -7. Okay? And the last one, we are not in the real plane, right? We could say 7i. We could say that, but for this chapter we are not going to worry about it. So that's an important fact. A root undoes an exponent. In fact, it undoes it exactly. So if I had the 4th root of -100 to the 4th, well, what's the answer? -100. Okay? So the 4th root undoes the 4th exponent. I would not multiply that out. Okay, we are going to do a bunch of examples on